Okay, this is going to be a little quick, not how quick it's going to be, an overview of the two types of trig integrals you're going to see. This is the first one with involving sines and cosines. Why they're paired, very simple. The derivative of sine is cosine, derivative of cosine is negative sine. This is why they go together, because you can always replace one with u and the other one's going to be du. These are always done by substitution. Now, there's a bunch of rules I'll go over quick and then I'll write them. But basically, there's only a couple of things that could happen. One of the powers would be odd, one of the powers could be even. You can have them both being odd, or you can have them both being even, right? I mean, those are the only things that can happen. They're both even, they're both odd, or one's odd, one's even. So depending on the situation, you're going to split them up differently. Now, I'll be honest, if they're both even, you are kind of screwed. It's the worst scenario is if they're both even. You have to do some really, really advanced and complicated manipulations there. So hold on. Okay, so poof, I wrote all this stuff. The identities that you're going to use, I wrote there on the side. And again, I wrote a quick overview. One of them could be even if only one of them is, excuse me, one of them odd. Sorry. If one of them is odd, then that means that the other one is even, right? So you would take the one that's odd and split it up like so. If you had sine to the third, right, you would split it up as sine squared times sine. Now, the one that you pulled off will be the du. That means that the u is the opposite of whatever you pulled off. So whatever you pull off here. If this is sine, then the u is cosine. If this had been cosine, then the u would be sine. The u is always the opposite of the one you took. Do not think about switching a sign. It doesn't work that way. It doesn't mean, oh, the u would be negative cosine. No. The u is either sine or cosine. So depending on which one you would split up. Now, if they're both odd, let's say you had sine to the third, cosine to the third. You picked a smaller one, but what if they're the same? If they were the same, you would split up the cosine because that would mean that the u would be sine. It's always easier to have the u being at the sine because the derivative of sine is cosine. Since the derivative of cosine is negative sine, that creates a little complexity you having to switch at the end when you do the u substitution. So I'd rather split up cosine, but if it was like this, let's say that was 3, and this one was, 9, right? Again, both odd. You would not want to split this up, trust me. You would split up the sine. So generally, you want to split up the smaller one. If they happen to be equal, then you split up the cosine. Now, if they're both even, you have a big problem. This is probably the most complicated integral that you could do, is if one was even. Excuse me, if they're both even. You have to use those formulas. And they're complicated formulas. This is one of them. I'm not going to write them both, but right, you'd have to use these other formulas, plug them in, multiply. It gets really nasty, really complicated. So I avoid asking these for a reason. So usually, almost always, you'll have one odd or two odds, and then you'll break them up. And you'll see when I do the examples now. Unfortunately for you, this isn't the only type of trig integral that you'll see. Okay, this time we're going to look at tangent, secant, powers. So again, same thing. It's going to be odds, it's going to be evens. These are more complicated because the derivative of tan is secant squared, and the derivative of secant is secant tangent. So they're a little bit more complicated to split up. There is a different identity that you need to use, but I'm going to show you where it comes from. You know that sine squared plus cosine squared is 1. Now, there's a little trick. If I divide everything by cosine squared, right? Now you get sine squared over cosine squared, but sine over cosine is tangent. So that gives me tan squared right there. Cosine over cosine is 1, and 1 over cosine is secant, and you have it squared, so that gives you secant squared. So this is a brand new, it's very similar to the ones that we used to do the sine and cosine ones, where you had sine squared is 1 minus cosine squared, and so forth. You're going to have a similar thing here. But in this case, you're going to get that tan squared is equal to secant squared minus 1, or secant squared is tan squared plus 1, right? I mean, that's already the thing. So you'd have tan squared plus 1. These are the two that you'll always replace after you do your very, very clever splitting up. So I'm going to give you a little rough guideline of how to split them. Okay, so like I mentioned, these are a lot more complicated to do. because of how the derivatives are. The derivatives are not, the derivative of tan is not secant, and the derivative of secant is not tan. So they're more advanced to split up. First thing you look for is if you see that secant has an even power, like 4, 6, 8, that's what you're gonna split it up. But you're not. You have to do it in a very clever way. If you had secant 4, you're gonna split it up as secant squared, secant squared. Why secant squared? Because the derivative of tan is secant squared. So in that case, you would be picking the u to be tangent, and then the du would be secant squared. This is why you need a secant squared, not a secant. You don't split up secant 4 as secant 3, secant 1. It doesn't. It's not the same as the sine and cosine one. This is a really different thing. So you'd have to split it up as secant squared. So this is probably the best case scenario for you, is that if secant is even, doesn't matter what tangent is there. Tangent could be odd or even. It's irrelevant. All that matters is secant is even. But if secant is odd and tangent is odd, now this is really important, right? So if they're both odd, then what you would do is, like, let's say it was tan 5 and secant 5. I should be writing S. I mean, I write S for sine. So if it was tan 5, secant 5, you would take one of these away and make it tan 4. You would take one of these away, make it secant 4, and then you would have a tangent secant that you would use as your du. So in that case, the u would be secant, right? Derivative of secant is secant tangent. So this one's not that bad. Again, if you see two odds, you're going to take one from each as your du, right? It's always splitting them apart so that you can create a du. Now, the last scenario, if secant happens to be odd, see, this one says both odd, right? Here, secant's even. If secant is even, you're golden. Doesn't make a damn bit of difference what tangent is. If secant is even, you're splitting them up. If they're both odd, then you have to split them both apart. But if secant is odd and tangent happens to be even, so if you had something like this, tangent squared, secant to the third, then you got a big, big problem. This is bad, bad integral. No matter how you try to split this up, it's not happening. You got to do some really complicated, you got to mix in integration by parts, and it gets really nasty. So this is the one that screws you. This is the bad one. These two are doable. And you will certainly see one of each of those 100% certainty. And you just pray that you don't see one of these, because it's really, really complicated. All right, so that's, I say brief overview, but it's never that brief. But this is the idea. This is it. They don't do one with cosecant and cotangent, even though they're similar with the derivatives, right? The derivative of cotan is negative cos squared. They don't do the trig integrals with those two. They do them with sine and cos and tan and secant. So now work examples from the worksheet so you can actually see how they're done.